Hello guys, how are you doing? This is Mahyar and you're watching the second episode of VHDL tutorial. In this video we're going to talk about entity section in details. Before we continue, don't forget to like and subscribe this channel for upcoming videos. Last episode we mentioned that every module has only one entity, and in this section all you need to care about is inputs, outputs, and buffers. Now let's dive into details. When writing your entity, the first step is to name it. Entity name must follow these rules. First, they must not be the same as predefined VHDL keywords like AND and OR. Second, they must not start with a number. And third, they must not contain spaces. Choosing a clear and meaningful entity name is crucial, especially for large projects. After naming your entity, you should know that an entity could consist of two parts, generic and port. What do I mean by saying could consist of instead of must? Because generic part is optional, and in some cases, such as writing a test bench, the entity part can be empty. To understand generic, first you need to know about port section. The port section is the most important part of your entity because it defines the inputs, outputs, inouts, and buffers on your module. As you can see in the picture, a port must follow this format: a port name, a column, a port direction, and a port type. Port name is the identifier for the port. Direction defines where it is in as input, out as output, in-out as both of them, or a buffer. You're already familiar with inputs and outputs. Now what's in-out? An in-out port allows a signal to function as both input and output at the different times. So you can receive inputs and write outputs dynamically with a single port. Now what's a buffer? A buffer is similar to an output, but it can also be used internally as feedback. In many cases, you might need to reuse a module's output inside itself. Keep in mind that you can also use signals for internal feedback instead of buffers. We will discuss signals in upcoming videos. After defining the port directions, we need to specify the port type. Port type can be a bit, boolean, integer, and if you use stdlogic 1164 package from IEEE library, you can use stdulogic and stdlogics as your type. The stdlogic type is the most widely used in VHDL. It allows a port to hold multiple states, including 0 as logic 0, 1 as logic 1, H as weak 1, L as weak 0, X as force unknown, U as uninitialized, Z as high impedance, dash as don't care, and W as weak unknown. The difference between stdlogic and stdulogic is from when multiple drivers happen, which we are not going to talk about them here. In VHDL, a port can store multiple values at the same time. For example, an 8-bit port can hold 8 separate values at once. If you want to define an 8-bit port, you need to use bit vector and specify its range using either down to or to. For example, if you write bit vector 7 down to 0, it means that your port has 7 positions, where the leftmost bit holds the most significant value and the rightmost bit holds the least significant value. On the other hand, if you write bit vector 7 to 0, it will be the opposite. The leftmost bit will hold the least significant value and the rightmost bit hold the most significant value. Keep in mind that vector command can be used not only for ports but also for signals, variables, and other data types. Now let's talk about generic section. A generic allows you to define constant value that can be used inside an entity. For example, as you can see in the picture, the constant data width is defined as natural number with the value of 8, and it's later used in port section. But why should we use generics? Without generics, if you want to change data width, you will have to manually modify multiple values across the hundreds of lines of codes. And if you use generics, you only need to change one value and it's automatically updated everywhere in the code. This makes your design more flexible, scalable, and easier to maintain. Generic values are not the only use for defining port width. For example, in this picture, a generic value is being used inside the architecture part to define a width of a signal dynamically. This is the reason why professionals VHDL engineers like you should use generics from the beginning to make their design more flexible and efficient. And that's it for the entity part in VHDL. If you find this video useful, please like and subscribe for upcoming videos and share this video with your friends. Don't forget to leave your thoughts on the comments. Until the next video, take care.